right, so this lesson is going to be on page 3 in the new packet. Today we're going to be finding arc length, or using the arc length formula to find more than just arc length, and the area of a sector. Okay, so I want to show you some Greek letters, maybe not necessarily in this lesson, because most of the time we're talking about angles, we use theta, but it doesn't have to be theta. So don't panic if later you see that this one, or one of these two, which is phi, you can use that for an angle. Any Greek letter, really, except omega. We'll use omega for something else. Alpha is fine, beta is fine, gamma. Those are all Greek letters that can be variables. So don't panic if it's not theta. So it's no big deal. All right, I'm saying it because it's definitely happened before. All right, so we are going to talk about the arc length. So we know that the circumference of a circle is given by c equals 2 pi r. I hope you do remember that from geometry, because sometimes they put that on the ACT. But r is going to be the radius of the circle, or sometimes it's pi times the diameter. But let's focus on 2 pi r. This formula can be used to find the length of an arc intercepted by some angle theta. So the circumference is the distance all the way around. And we know the angle in radians all the way around is 2 pi. I'm drawing some real good circles today. But we don't want all the way around on these. We just want a piece of the circumference, not the whole circumference. And so what this formula is the angle all the way around the circle times the radius of the circle. So we're going to do the same thing. Is the radius of the circle times the amount of the angle that we want. We don't have to find the whole circumference. We can just find a partial circumference, which is considered to be an arc. All right, so to use this formula, r is measured in linear units like inches, feet, centimeters, something like that. Theta needs to be measured in radians, so that's important. And S is measured in the same linear units that R is measured in. Now, I had some students a few years ago, I saw them draw this, and I thought it was really cool, and I think their chemistry or physics teacher showed it to them. So when you have a formula like this one, where something equals two things multiplied, you can draw this triangle thing, or you can make it a circle. I think normally it's a triangle. It's like a little T, right? What the function normally equals, which is S, goes at the top, and then the other two that are multiplied go bottom. All right, so maybe that's familiar to you, I don't know. But then if I want to find S, then I just multiply R times theta. If I wanted to find R, you kind of cover up R, and then what's left is telling you to divide S and theta. And if I wanted to find theta, cover that up, and then we're going to divide S by R, sorry. So this is kind of a cool thing to use. We're going to use it again tomorrow on a different formula. All right, so for example 5, we want to find the arc length of the arc with radius 4 inches and theta, or central angle, whatever you want to call it, of 60 degrees. Now, to use this formula, the theta has to be in radians. So we would need to take a second and change 60 degrees to radians. To change degrees to radians, you multiply by pi over 180. And then if I want to reduce that down, a 0 and the degree would cancel. So it leaves you with 6 pi over 18, which reduces to pi over 3. Okay, and then to find the arc length, to use the formula, I'm just going to multiply my radius by that angle. Okay, and then remember to multiply fractions, we just multiply across the numerators, which is 4 pi, and across the denominator, which is 3, and then that's going to be in inches, just like the radius was in. All right, let's look at the next one. So if an arc length is 6 inches and a radius is 2 inches, find the central angle in degrees. All right, so this one, I'm looking for theta. So I'm going to do that thing where I want to find theta, kind of cover it up, and then you do S divided by R. So theta, the arc length is S, the radius is R, obviously. So it's going to be 6 divided by 2, which is going to be 3. Now, is that 3 degrees? Because it told us to give it in degrees. It isn't. It's 3 radians. Now, radians doesn't have a unit. So if you're finding an angle and you finish it and there's no unit, it's definitely radians. For it to be degrees, you have to see the degrees. And so all we have to do now is change 3 radians to degrees. All right. And to change radians to degrees, you multiply by 180 degrees over pi, which is going to be 540 degrees over pi. All right. Now, some people don't like the way that looks, and if you want to know what that is as a decimal, you would just go to your little calculator and do 540. Now, our little calculators that we have don't have pi, so I'm just, on these problems, I'm just estimating pi as 3.14. All right, so that is going to be, oh, I typed in 3.17. Let's try it again. All right, so that is going to be approximately 171.97 degrees. Now, I'm fine with you leaving it as 540 degrees over pi. Like in the answer key, I think I put both of them. So you don't have to change it. Sometimes the calculator makes you make a mistake. So you can leave it the other way if you want to. All right, so for example 7, if the arc length is 2 meters and the central angle is 125 degrees, find the radius. All right, so this time I'm looking for the radius. So I'm going to cover up R to find the radius. It's S divided by theta. Okay. So our theta again is in degrees. So let's change that. Okay, this time degrees cancels, but a 0 doesn't, which makes it a little harder to do. But I do know 5 goes into both of these things. 5 divides into 125 25 times. And then 5 divides into 180 36 times. And that won't reduce anymore. Okay, so now I am going to use this formula. I'm going to switch it up a little bit. It might be easier, instead of dividing by theta, that we multiply by the reciprocal of theta. Okay, so R is going to be our S, which was 2 meters, times the reciprocal of theta, which is 36 over 25 pi. So then I would just multiply across my numerator. 2 times 36 is 72. Multiply across the denominator, that's 25 pi meters. Now, if you don't like the way that looks, I just want to show you how to type it in the calculator. So I'll close out my calculator. All right, you're going to do 72. Now, we can't just, our calculator's not that smart, so what we would do is we would divide by 25, and then we would also divide by 3.14. But I'm fine with you leaving it as a fraction, really, I promise. All right, let's look at example 8. the arc length of an arc with, or find the arc length of an arc with a radius of 3.5. Didn't give a unit. Let's say it's centimeters. And theta of 100 degrees. Now, if you choose to leave this one as a fraction, we can't leave a decimal inside of a fraction, and we'll talk about that when we get to it. So, again, theta is in degrees, so I need to change it to radians. Now, when you guys go to do your assignment, if your angle is in radians, you're like, sweet, don't worry about it, just be done. Use that angle. But if it's in degrees, we just need to make sure we change it to radians. Okay. All right, so now I am looking for S. So when we're looking for the arc length, you just multiply the radius by the angle. Okay. So you can use your little calculator, multiply 3.5 times 5, that's going to be 17.5 pi in the numerator, 9 in the denominator. Now, this isn't great for leaving your answer. Now, I'm okay with it like being a fraction, but I'm not okay with it when you have a decimal and a fraction. So it's not a big deal. We'll just multiply by 2. So it's going to be 35 pi over 18 centimeters. Okay, so that is the arc length formula. All right, there's another formula we need to learn today, and it's the area of a sector. All right, so we know from geometry that the area of a circle is found by a equals pi r squared, where r is the radius of the circle. This formula can be used to find the area of a sector. So a sector is like a partial circle, section of a circle. So if you've ever played Trivia Pursuit, I don't know if you guys do that. Like a piece of a pie, that's how I think of it, or a slice of pizza. You guys have eaten pizza, so that probably would be a better example. But this right here is a sector. It's like a slice of pizza. So we don't want the whole circle, which would be, it looks like basically it's half a rotation. So half of 2 pi, or just pi times r squared. So we do half of whatever angle we are using for our sector times r squared. Right? Again, r is in linear units, and theta is measured in radians, and then the area is measured in square units. All right, so for example 9, we are going to find the area of a sector with radius 8 centimeters and a central angle 75 degrees. So degrees, again, means we need to change our theta to radians. Okay, and then we'll just reduce. As I know, 5 goes into 75 and 5 goes into 180. I think there's something else, but 5 is easy. And then 3 goes into them also, so we would then reduce by 3. Okay, so the area of the sector formula, we're going to do 1/2 times our theta that we just found, that's in radians, times the radius squared. All right. All right. So we are going to, anything in the numerator, we're going to multiply by, and then denominator, we're going to divide by. Let's just multiply the numerator first. So I'm not going to do the pi though. So it's going to be 5 times 8 squared is 64. So that's 320 pi. Sorry, I'm pausing. I've just been making some crazy mistakes when I did this earlier. All right, and then in the denominator, it's 2 times 12, which is 24. All right, they can definitely both reduce by 8. I don't know if they'll reduce by anything bigger. No. So we would just do 320 divided by 8. We can do that in our head is 40, sorry. So 40 pi. 24 divided by 8 is 3. And then this is going to be, since this area, centimeters squared. Okay, let's look at the next one. For example 10, a sprinkler on a golf course fairway sprays water over a distance of 70 feet and rotates through at an angle of 120 degrees. Find the area of the fairway watered by the sprinkler. All right, so same thing. This kind of weird way of telling you that the R is 70 feet here, and then angle is 120 degrees, but we do need to change that to radians. So area is equal to half the angle times the radius squared. Now I'm going to reduce those 2's because I now have a 2 in the denominator and a 2 in the numerator. That will cancel out. 70 squared is 4,900. So that pi up there, and then the 3 on the bottom. And that originally was feet, so the area is going to be square feet. All right, and the last example of today, for example 12, a pointer on a voltmeter is 6 centimeters in length. And so you can see the figure. Find the distance the tip of the pointer moves if the angle of rotation is 20 degrees. We don't need that extra word there, sorry. All right, so this one, are we doing area or are we doing arc length? This is definitely arc length. So we're going to use the arc length formula. If we're finding the distance the tip moved, what we're trying to find is the S. But we need to make sure we change our angle to radians. All right. So then our arc length is going to be our radius times theta. Our radius is 6. Our theta is pi over 9. So that's going to be 2 pi over 3 centimeters. Now remember, arc length is just a linear unit. Area is a squared linear unit. A squared unit, sorry. Let's look at day on the back. We're going to write in the assignment for today. I do want to give you a little hint on one of them, or two really. So on pages 359 to 360, I want you guys to do 15 through 24. Now on maybe 19 and 20, can't remember for sure, it talks about the angle is 5 minutes. And then it tells you that 1 minute is a 60th of a degree. So there's 60 minutes in 1 degree. So if I want to change that 5 minutes to degrees, we would multiply it by 160. So that's 5/60 of a degree, or 1/12 of a degree. So you're going to need to do that on 2 of them. It gives you minutes instead of degrees. You just change it by dividing by 60.